Got to give the people get the people what they want. The people want to talk about these log equations. Man, it's a Sunday morning. I'm feeling good on these streets. So let's talk about some log equations because that's what everybody wants to spend their time doing. I know, it's cool. You don't have to pretend like it's not true. So write this down in your notebooks. Solving base 10 log equations. Bong, bong, bong. So what is that? Right? A log is an inverse operation that undoes a base. The most common base to be undone is base 10. So that's the one we're going to focus on here today. So what does this mean? This means that I can use logs to isolate variables when the variable is in an exponent spot. Like we know what to do when the variable is not an exponent spot. If it's being multiplied, we divide. If it's being added, we subtract. Even if it's being squared, we take a square root. But now we have this different inverse operation, which is a log. And that's going to undo a base. So let's talk about, and we're just going to do it through examples of some ways how this could work. So go ahead. Nope. Wrong. Go ahead and write down example 1 for me. It says 10 to the x plus 9 equals 73. Let's write that down and let's think about it. All right. So I know that I want to isolate this right here, but first I got to get rid of that plus 9. So as we all know, the way I'm going to get rid of plus 9 is minus 9. And whatever I do, I'm going to do it on both sides. Please, as you're doing this equation, show all the work. Don't skip any steps. Show what's happening on each side of your equation. So on the left side, I'm left with 10 to the x equals whatever 73 minus 9 is, which I want to say is 84. Ooh, I hope that's right. I think it is. All right, cool. So now I'm left with 10 to the x equals 84. So here's where it's new, right? We have x in the exponent spot, and we don't know how to deal with that. This is new. So how do I get rid of this base of 10, right? 10 is a base. So this is the base 10. How do I get rid of that? The way that I get rid of any base is by taking a log. So I'm going to go to undo this. I'm going to do the log base 10. And those are going to cancel. And I'm also going to do the log base 10 on both sides. So I got to like smash it in there. It's kind of weird. And I'm going to rewrite it in a second. So the log base 10 cancels out base 10. That's what I want. And I'm left with x. That's what I want. Nobody wants to know anything else, but what does x equal? And on this other side, I have the log base 10 of 84. Notice how I wrote this. The log base 10 is at the bottom, right? It's small. It's clearly at the bottom. 84 is right on the same line with the log. You want to pay attention to those details and write it in the same way. So I have x equals whatever the log base 10 of 84 is. That you will be able to do on your calculators. Calculators have a little log button. So the log, it's actually going to say usually just log, and they assume that it's base 10. And we're going to talk about this in class. So literally in your calculator, you would just hit the log of 84. You don't have to put base 10 because that's what your calculator assumes. And when you do that, let's see, log of 84, you get x equals 1.924, blah, 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 blah. Whole bunch of stuff, but about 1.92. All right? So what does that mean? That means if you took 10 to the 1.92 power, you'd get about 84. All right, let's do number 2. We're only going to do 4 of these. Go ahead and write down number 2. It says 11 times 10 to the x equals 8,562. Again, we're going to do what we know. We know we want to get 10 to the x alone to begin with, and we see that that is being multiplied by 11. So to get rid of that, I'm going to divide by 11. So I'm going to divide by 11 on this side, divide by 11 on this side. These cancel. So I'm going to end up with 10 to the x power equals whatever 8,562 divided by 11 is. 8,562 divided by 11. And I get about 778.36. We'll call it that. There's more, but we'll just call it right there. All right? And do it for yourself. Make sure that you don't just believe me. I mean, I can make a mistake. I'm only human out in these streets. All right, so you did that. What's the next step you think you're going to do? Go ahead and do it right now before I do it. Pause. You did it. Boom. All right, coming back, you looked at it and you said, okay, well, I see that x is in the exponent. So the only way I know how to get rid of this base of 10, the only way I can get rid of a base period is to take the log. So I'm going to take the log base 10 of 10 on this side, and I need to do the log base 10 on the other side as well. I kind of got to smash it in. These cancel. Most important part, the fact that those cancel and they just leave me with x. That's what I want to know. So x is whatever the log base 10 of 778.36 is. Again, you can do this in your phone. You have a button that says log or log base 10. But when you calculate this, you can also do it on Desmos, and I don't know what it is, so let's see. I have 778.36, and I'm going to take the log base 10 of that. And my calculator tells me that's about 2.89. Okay, so literally you just like in your calculator log 778.36. Again, your calculator might not show this base 10 because this is assumed. It's assumed you're always working with base 10 on most calculators. Two more. Ooh, this one's looking crazy. Write down example number 3. It says 10 to the x minus 6 minus 17 equals 9,732. Boom. You wrote it down because, I don't know, you follow directions and you're like, yeah, I should probably think about this because then I'll be able to do it for myself, and thinking is really cool. So that's what you were doing. Why don't you try to solve this without me? You paused it. You tried to solve it. Now let's just check to see if you did it right. So first thing I'm thinking is I want to get this thing all by itself, 10 to the x minus 6. So how do I go about doing that? I got to get rid of minus 17. And the way I would do that is plus 17 plus 17. These cancel. That becomes 0. I get 10 to the x minus 6 equals whatever this is. I have no idea. That's a 9, that's a 4, that's a 7, and that's a 9. Cool. So 10 to the x minus 6 equals 9,749. All right. Now I have an x in the exponent, right? I have a base of 10. The only way I know how to get rid of the base that is 10 is by taking a log of the base 10. So let me do that. Log base 10. Log base 10. Ooh, I had a little spot to fit it in there. Ooh, I'm smart. Sweet. All right, what happened over here? These canceled. That is what I wanted. I want to get x minus 6 by itself. And now on this other side, I have to take the log base 10 of 9,749. For this part, go ahead and calculate that right now. While you all are calculating it, I'm going to calculate it as well. 9,749 log base 10. If you did it, you should get that equals 3.989, something like that. Something real close to 3.98, 3.99, okay? So I'm left with x minus 6 equals 3.989. Now I just got to keep finishing it off. Well, I need to get x by itself. What's happening right now? It's saying minus 6, so I have to do the opposite, inverse. Plus 6, plus 6. I end up with x equals 9.989. There is my final answer. One problem left. Write down example number 4. Solve it without me. Pause it right here and solve it. Cool. You just did that because, again, you're a direction follower. I know. So I'm thinking, all right, I got to isolate this piece, okay? I see it's not isolated because 8.4 is being multiplied with it. So I need to undo that. I need to get rid of that multiplication. So I'm going to divide by 8.4. Divide by 8.4. And I'm left with 10 to the x equals whatever 11,900 divided by 8.4 is. So let's see, 11,900 divided by 8.4. And I get 1,416.66. That's actually, we should say 0.67. All right, now it's looking like something I can deal with. All right, so now, still trying to get x by itself. I got to get rid of that base 10. How do I do it? I take a log of base 10. And I need to take a log of base 10 over here. Again, sometimes it gets hard to write, but I'm still going to show that I'm doing it on both sides. These cancel. So I'm left with x. And I got to figure out what is the log base 10 of 1,416.67. Now it's just calculator work. 1,416.67. And I'm going to do the log base 10 of that. And I get 3.1512 something. But we'll just call it about 3.15. Boom. Right? Which means if I took 10 to the 3.15 power, I should get 1416.67 or something pretty close to that. Why don't you check it right now? See if that's actually true. 10, I'm going to do it, and you're going to do it as well. 10 to the 3.15 power. Oh, snap. It's about 1412.53. That is close enough. There it is. That's what you got. It's all done. Wasn't too long. We're going to be doing this in class tomorrow. Hopefully y'all are good. Hopefully everybody had a good weekend. Keep holding it down. We got like 3.5, 4 weeks of school left. I don't even think it's that before the break. So we're doing good. All right. Peace.